Guys, welcome back to Maison African Motives. Still on mathematics and 5, working on derivatives. We shall be taking a closer look into our implicit functions, in this case, that is on our differentiation. I explained about the other part of derivatives, and this is another part that you are supposed to also understand in your syllabus, the application of implicit function. What exactly are we referring to an implicit function? These are functions that are actually very difficult for us to make either x or y the subject. Like what you're given here, for you to make x or y the subject there, it is very, very complicated. So on that condition, you are supposed to find the derivative of y with respect to x. But having an expression that has got x and also has got y, how are we going to determine the derivative of y with respect to x on that condition? That is the question. All right. We know that if we are given, let's say y is equal to 3x like this, it's just easier for us. We say dy dx there is equal to 3. All right. There is nothing that we can do or multiply with. We are just finding the derivative direct. Here there's a 1, you multiply this by 1, we subtract 1, which is going to give us x to the exponent of 0, which is 1, times 3, which is 3. But if we are given now to find a derivative with respect to x of 3y like this, it's no longer 3x, it's 3y. But as we are supposed to calculate the derivative with respect to x, which is impossible because this one, it's not with respect to x, it's with respect to y. But we need an answer for dy dx in this case. What are we going to do? You are going to find the derivative of this function that we are given, which is in this case the derivative of 3y, which is 3. Just like 3x, it's a 3. But the answer now is going to be multiplied by dy dx. So this is how you differentiate an implicit function. 3y cannot be differentiated with respect to x. So you just differentiate as it is with respect to y, then you multiply times dy dx. I just hope we are together in this case. All right, so this is the part that we are going to be working with. Here I'm just explaining so that we can just have a basic approach of these questions that we see here, so that we note how are they giving these questions. All right, so given a consideration before we check into this PDF, we've got this part here. Let me explain before this one. Let me explain this one before we talk about this with the normal algebraic. Before we talk about the course, let us have a normal algebraic expression. For an example, let's say we are given to find the derivative of y with respect to x, and we are given xy plus x squared plus xy is equal to y squared. And we can see that it's very difficult for us to make y the subject or even x the subject. And there you are asked to find the derivative of y with respect to x. So what are you going to do? You are going back to the concept that I was explaining, that wherever there is x, you differentiate properly. But where there is a y, you differentiate that part of y, you find the derivative of y that you are given, you multiply to dy dx. So that means in this case, we are going to find our derivative. Let us start with the x squared. So there we have got x, the derivative with respect to x, it is going to give us 2x plus, let us take a consideration. Remember, y is a function in this case. It's not a constant. We are not considering y as a constant to say if you differentiate with respect to x, a constant, it is going to give us a 0. No, y is considered also as a function. So meaning to say, once we've got a function, this is a function, this is a function. So we are going to apply the product rule in order to, because these two functions, they are multiplying each other. Because y is also a function. Yes, it's not a function of x, but it's considered as a function. So here we are going to have u and v, applying our product rule, which is u times the first derivative of v plus v times the first derivative of u. All right, which is we are adding here. So we are going to see the answer that we are going to obtain after adding after having everything. So you're just going to have a bracket. You don't know what's going to happen there. So this is u, which is our x. So that is going to be x times the derivative of v, which is the derivative of y. This one, it's a function of y. And I said the derivative for a function of y, I mean, if you're dealing with the y, you find the derivative of that y times dy dx. Take note, the derivative of that function, we need to say the derivative of y is 1 times dy dx. So that is how you differentiate y with respect to x. Okay, plus v, our v, which is y, we are going to take y as it is, times the derivative of u, which is our u, it's x. Remember, it's with respect to x. So we're just going to have a 1 in this case, okay? So that is equal to, there, we have to differentiate again each and every term. So again, here we've got a function of y. Whenever there's a function of y, you find its derivative. That is the derivative of y squared, which is 2y times dy dx. Once you understand this, guys, you are done with your implicit functions. All right, so this whole part here, I'm just going to close the bracket, simplify. This is a product, so you're going to have at the end 2x plus x times 1 times dy dx, which is going to be x dy dx in this case. This one is just like a 1, so it's 1 times y times 1, which is going to be y in this case. All right, so everything is equal to 2y times dy dx, which is 2y dy dx. Remember, our question is to find dy dx. This is what we need. So we have got dy dx here, we've got dy dx here. So what are we going to do? We are going to collect these terms one side of the equation. We are going to take these terms to one side of the equation, depending with what you want. You can take this term this side, or you can take this term this side. This one, it's your choice, all right? So let us just say I took this term this side. What was going to happen? Okay, so let's see what was going to happen here. I was going to remain with the 2x on this side and this plus y, okay, which is equal to, I have transposed this to the other side of my equation. So it's going to be a negative there. So already we are having what? We are having 2y dy dx. We transpose this to the other side. It becomes a negative since it was a positive here. So it's going to be x dy dx. What's the purpose of collecting these terms together? All right. So that we can factor out the common term, which is dy dx. But in this case, like I said, we could have transferred this one to this side. It still was going to be one and the same thing, all right? But I was just avoiding to say, when you transpose this to the left-hand side, it means y is going to transpose as a negative, 2x is going to come here as a negative. So, but it's fine like that. We can have the same answer. They will be like different in terms of our presentation, but they represent the same answer, all right? So in this case, what you're going to do is to factor out what is common, which is dy dx, which is a common term. So that is the one that we are supposed to work with. So the moment I factor dy dx here, what am I going to remain? Remember, if you factor out, you divide. So we are going to remain with the 2y minus this one, and this one cancels. You remain with x. So to find dy dx, we are going to divide both sides by this bracket of 2y minus x. So that means here we are going to obtain 2x plus y over 2y minus x, because we are dividing by this bracket both sides of the equation in this case. So this is a normal algebraic part that I was trying to explain, to say when you are given x times y, it's a product. There, you are not considering y as a constant, you are considering y as a function. So you consider that as a product. All right, so let us check what we have in this case here. Now we are given to determine dy dx from our implicit function. That was 5 marks. All right, so this is 5 marks that we have here. Let us see what we are supposed to do in this case. Remember, we are supposed to consider each term, finding the derivative of y with respect to x. So in this case, we are to start this part here. Let us start with this part. What does it mean actually? We are having a course in this case. It's a course. Okay, let us consider the derivative of a course. we know that if we are dealing with the derivative of with respect to x of cos f of x, it is going to be minus first derivative of this f of x by sine f of x. All right, this is what we understand from our course. All right, meaning to say this whole part here is referred to as a function of x, whereby we are supposed to determine its derivative. That is going to be minus f of x in this case because it's a cos. So meaning to say we are supposed to find the derivative of this part. So we are going to have minus the derivative of this part that we have inside the bracket. So let us start with x squared. What is the derivative of x squared? It is going to give us 2x with respect to x. We move on to 2y. 2y is a function. So remember, whenever you're dealing with a function of y, you're going to find its derivative times dy dx. So what is the derivative of 2y? That is going to be 2 times dy dx. All right, so that is how you deal with your implicit. But remember that we are dealing with the first derivative of f of x in this case. Whatever that you have must be multiplied to sine f of x. That is, if you are differentiating cos, so we are going to multiply to the sine f of x, which is this whole expression as it is x squared plus 2y like this. So we have differentiated the first part of our function, which is the part of what? The part of cos. We move on to this part here. These two functions, they are multiplying each other. This is a function of x. This is a function of y. Remember what I said? Y is not a constant, it's a function. So meaning to say there we are talking about a product where we've got u and a v. And we said the derivative of a product is going to be u, the first derivative of v, plus v, the first derivative of u. So that's our u in this case, which is x. So we are going to have plus x times the derivative of v. We are differentiating e to the exponent of y. All right, that is in this case y. We have to find its derivative, e to the exponent. All right, remember on a normal circumstance, if you differentiate let's say e to the exponent of f of x, this is what we are used to. It gives us the first derivative of f of x times e to the exponent of f of x. But this time we are talking about the derivative of f of y. So meaning to say this one was going to give us, this was our f of y in this case. So we need the first derivative of f of y, e to the exponent of f of y. So the derivative of y squared is 2y. So this was going to give us 2y, e to the exponent of what? Of y squared. So this is the first derivative of what? Of y in this case. But whatever that we have must be multiplied with what? Dy dx. Whatever that we are going to talk about must be multiplied with dy dx because it's an implicit part there. So that is the whole part here. For the derivative of v, it is going to give us 2y e to the exponent of y squared times dy dx like this. All right, we move on to the other part of our simplification. We're here at this part. We are now at v. So this u, we took the u as it is. Then the first derivative of v, which is this part, the first derivative of v. So we are going now to the v as it is. So we're going to take our e as it is, e to the exponent of y squared times the first derivative of u, which is the derivative of x, which is going to give us a 1. All right, this is equal to, remember, the derivative is taken throughout up to the last part of our value, which is the derivative of 1 with respect to x is going to give us a 0. 1, it's a constant, it's a number, this one. All right, so this is what you are going to have. From this part, you are supposed to play around and obtain an expression for what? For dy dx. So what can we do? Here there's dy dx. So meaning to say, there is a need for us to expand our brackets because this dy dx is inside the bracket. So take note from this part here up to this part. This is the part that I'm talking about. So we are going to consider this negative and this sign to multiply this bracket so that we separate this dy dx, all right? So it's going to be negative sine x times 2x, which is going to be negative 2x sine x squared plus 2y like this, all right? You do the same thing, negative times this 2, dy dx times this sign, because you're expanding, so it's going to be negative 2. We can take the sign there, sine x squared. All right, that's sine x squared, sorry for that, plus 2y like this times the derivative of dy dx. It must be there. So take note here how we are expanding. We are saying these two terms must expand the bracket. The negative must expand the bracket. The sign also is affecting this bracket, so it must multiply these two terms. All right, so we are done with this part. We move on to this part here. We can just multiply everything here, just combine everything. So this is going to be plus, we can start with our constant 2, so it can be 2xy e to the exponent of y squared dy dx. All right, that's dy dx like this, plus e to the exponent of y squared times 1 is going to be e to the exponent of what? Y squared, which is equal to 0. All right, so that's now we can see separately our dy dx here and our dy dx here. So we can transpose these two terms to the other side of the equation, depending with the way that you want to have your answer as. So we can choose to transpose these terms to the other side or dy dx to the other side. It's up to you on how to transpose this part, all right? So, but what we want is to remain with this term and this term, all right? So here I can just choose to factor, to leave this part, minus 2 sine x squared plus 2y like this, dy dx with this part of 2xy e to the exponent of y squared, that is dy dx like this. So I can transpose these other two terms to the other side of the equation, this part and also this part to this side, so that this will be this part to the other side of the equation, to the right hand side, it is going to be a positive. So it is going to be positive 2x sine of x squared plus 2y in this case. If I transpose this to the other side of the equation, it is going to be a negative. So that will be negative e to the exponent of y squared. So by doing this, we are simply trying to obtain or to remain with a dy dx on one side of what? Of one side of our equation. In this case, by having this, we can factor out this dy dx because it is common. So we are going to remain, if we factor out this, we are going to remain with this term, and here we are going to remain with this term. So that is what you are going to remain with at the end. This term, because you factored out, you divide these two cancel. These two, they cancel, you remain with these two. So you can even start by writing this one as a positive, or you can start with this one, guys. This one is up to you. So I'm just going to start with the positive one, 2xy e to the exponent of y squared, and I take the negative at the end, 2 sine of x squared plus 2y like this is still one and the same thing. All right, so I could have started with this, end up with this one with a positive, it's still one and the same thing. So this is equal to everything that we have on the right hand side, which is the sine of x squared plus 2y like this minus e to the exponent of y squared. So with this whole information, I can now determine dy dx because what is affecting is this bracket here. So I can simply remove my bracket here by dividing both sides to this part of the equation. So that means, therefore, we are going to remain with our dy dx, which is equal to divide by this whole bracket to this side of the equation. We are going to obtain 2x, the sine of x squared plus 2y minus e to the exponent of y squared. Everything over this whole bracket that we had divided, which is 2xy e to the exponent of y squared minus 2 the sine of x squared plus 2xy like this. All right, so that's it. We have determined our dy dx from the implicit concept, that is the application of our implicit what? Differentiation. All you need is to understand the concepts that you are given. The concept is that simply differentiate each and every part that you're given with respect to x. Where there is y, you find the derivative of that function of y, then multiply to dy dx. But where there is x, you are differentiating direct because it's already with respect to x. So it's going to depend with the typical questions that you will be given. Like for example, let us check another part that we are given here. In this case, they gave us an expression, an implicit function, which is 2 sine x cos y is equal to 1. Determine dy dx from this part. All right, so let's see what we are supposed to do here. 2 sine. So we are given the 2 sine of x. All right, sorry for this. So this is the 2 sine of x cosine of y is equal to 1. Then we are asked in this case to find the derivative of y with respect to x. That was the first item here of 2.51. So what are we going to do in this case? Again, find the derivative, but as you can see from this part, this is a product. This is a function, this is a function, like I said. So we have got u and v. So using our product rule, we are going to have u, the first derivative of v, plus v, the first derivative of u, which is in this case u. We are going to take our u as it is, which is 2 sine x. So that is going to be 2 sine of x multiplied the first derivative of v, which is cosine of y. Remember, whenever there's a function of y, don't forget the concept, first derivative of y times dy dx. So we're going to find the derivative of y, which is cos, gives us a negative sine y in this case. But whatever that I get here, I multiply to dy dx. So if we are, whenever you are dealing with a function of y, find its derivative multiplied to dy dx. All right, so that was the derivative of what? Of v. We move on, plus v, our v we take this time as it is, which is the cosine of y. We are not differentiating, but we are going to differentiate u, which is the 2 sine x. So 2 sine x, this one is already with respect to x. So we're just going to differentiate this. We could change to a cos. There's nothing that you're going to do there. It is equal to the derivative of 1, which is the derivative of a constant, gives us a 0. So let us try to simplify, expand our brackets here. We're going to have, that's a negative here. So we are going to have negative 2xy. If we multiply 2 times negative, that will be negative 2 sine of x, sine of y, in this case, times the derivative of y with respect to x. We multiply also this part, you're going to have 2 cos. So that will be 2 cosine of x, cosine of y is equal to 0. Remember, our main aim is to obtain dy dx. So we are supposed to transpose this term to the other side. That is going to be negative 2 sine of x, sine of y, dy dx is equal to, if we transpose this to the other side of the equation, this will be a negative. So we've got negative 2 cosine of x, cosine of y, because it was a positive in the first place. All right. So to find dy dx, what are we going to do? Simply divide so that we remain with this dy dx. So we divide both sides by this part of negative 2 sine x. So that's dy dx is going to be equal to negative 2 cosine of x, cosine of y, over negative 2 sine of x, sine of what? Sine of y in this case. All right. So that was what we're supposed to have, but we can even simplify further from this part here because we know our trigonometry. So we can say our dy dx here is going to give us this one, and this one cancels, which is going to be, this was supposed to be our answer. We're supposed to actually leave our answer here. But we know that from our trigonometry, guys, cos over sine, it's a cot. So meaning to say cos x over sine x is going to give us cot x. So that is going to be cot x times cos y over sine y is going to give us the cot of y in this case. All right. So that is, we can leave our answer in exact form as this. So that is the derivative of y with respect to x. Okay. The next part that we are given here now was, I want us to be very careful about this part. We are given now to determine the equation of a tangent. So there's a tangent to the graph that we are given at the point pi over 4 pi over 4. So this, you are given a point. We want to calculate the equation of a tangent, all right? We all understand that, all right, this is the concept of remember the concept of a tangent. If I am given a curve, let's say this is my graph that I'm having there, all right? We are just given a certain curve that we have. A tangent is simply a line drawn to the curve, touching the curve at that point. So at a given point of the tangents, which is where the tangent and the curve meet, these two, they are going to have the same gradient at that point of intersection. These two, they have the same point. That is, they lie at the same point because they meet at that point. So it's the same point where they are. So they are sharing the same point in actual sense. Having the same point, they also possess the same gradient. So meaning to say, the gradient at this point of the function, so which is dy dx. So dy dx representing the gradient of a function. So dy dx is the gradient of the function, which is our f of x or whatever that we have. So let us just say is the gradient of the function, is supposed to be equal to the gradient of the tangent at that point, which is m. So m representing the gradient of a tangent. Remember, a tangent is a straight line. So that's the gradient of a tangent at the given point, All right, so this is the consideration that you're supposed to take. The point that you remember, I'm talking about m here because we are talking about a straight line. And we know that the equation of a straight line is given by the form y is equal to mx plus c, where m here represents the gradient. So this m is the one that I'm saying it is equal to dy dx, which is the gradient expression of a function at the given point now. Meaning to say you are supposed to substitute the point that you are given here to find the gradient, which is m. So that was the stage there. So the point, remember, we are given our point there. It was given as pi over 4, meaning to say we have the value of x and the value of y. Once you are given these values of pi, it means we are referring to radians in this case. We are talking about radians. Your calculator is supposed to be in radians unless you convert this to degrees. So this is what you are going to do. You are supposed to substitute now because you want to obtain m, and I'm saying m represents dy dx at the given point, and this is your dy dx, which is cot x, cot y. But remember, we can't access cot on our calculator direct. We are going to change this to cos x over sine x and cos y over sine y, or we change this to cot x. It's same as 1 over tan of x times the cot of y is same as 1 over the tan of y. But remember what I said in radians. All right. So I want us to have these values. Remember the value of y, the value of x here and the value of y are the same, which is pi over 4. So using your calculator in radians, you are supposed to change your function here. Let me show you. So on your calculator, it's shift. Okay, what we want to change before we talk about this shift is this d here. If you check on your calculator, there's a d to mean that your calculator is in degrees. So if you do not want to change, you convert. Remember, pi represents 180. So that's you divide by 4, meaning to say your angle there, it's 45 degrees when you have to calculate here. So you're going to have 1 over, so you're going to have 1 over tan, remember it's tan x, which is tan 45, all right, sorry, which is tan 45 degrees like this, times 1 over tan y, which is 1 over the tan of y, which is also 45 degrees because we've got pi over 4 and pi over 4. So you're going to obtain 1. But using pi over 4, like I said, it's in radians. You are supposed to change your calculator, shift mod, you go to the 4. So the 4 there, it's in radians. You change this to rad. So it must indicate R there to represent radian. So you're going to use as 1 over tan, which is tan pi over 4. Remember your x there was pi over 4. So you're going to use pi over 4. So that's pi over 4 in this case like this. All right, multiplied to 1 over tan again y in this case, which is 1 over tan pi over 4 again. So this is pi over 4 in this case. All right. So we can use this direct, which is a 1, which is the same answer like the previous part that we got. So meaning to say we could have used in radians or in degrees, you are still obtaining the same answer. So like I said, this is how you find m. So m is equal to, you substitute here in place of what? In place of cot x, in place of dy dx. So that is dy x at that point now. So we're going to have 1 over tan pi over 4. Oh, sorry. So this is tan pi over 4 times 1 over tan y. Y is also pi over 4. So you saw that this value was going to give us a 1. So it means that the gradient there, we have it, which is 1. So the question is for us to find the equation. And I said the tangent and the curve, they are at the same point, having the same gradient, meaning to say the point that we are going to use to calculate the equation of a tangent is this one, because we said a tangent is a straight line. So meaning to say we are just going to substitute this part. Y is equal to mx plus c. So we are going to have y is equal to m, which is our gradient. So m, we obtain the numerical value there, which is 1. So that's 1x, which is x plus c. So we are supposed to calculate c by substituting the point that we are given, which is here x and y. So you substitute these values in radians in this case. So y there is pi over 4 is equal to x, which is pi over 4 plus c. So transpose this, pi over 4 minus pi over 4, they cancel. You obtain your c, which is equal to 0 in this case. So c was going to give us a 0. All right, so c was going to give us a 0. That's if this value here is a 0, therefore the equation of the tangent is going to be given as y is equal to x plus 0, but x plus 0 is same as what? Is same as x. So therefore, the equation of the tangent of this tangent that we are given at point pi over 4 is going to be y is equal to x. So that was the whole idea of how to answer this type of a question that you be given to determine the equation of a tangent to the graph. What you just need to know is that the graph and the tangent at that point, they possess two things that are the same point, the same gradient. But the gradient of a tangent is dy dx. I mean, the gradient of a curve is dy dx. The gradient of the tangent is m from a straight line, m representing what? The gradient. So that m, you're going to take it from dy dx because we are saying they have the same gradient. So if they have the same gradient, the gradient of the curve here and that one of the tangent, which is m, should be equal. So you take advantage because here you calculated dy dx from the curve, which is your function. So that's where you substitute the value of x and the value of y that you be given. So that was the idea of our question there. Then we've got another question again to find the derivative of y with respect to x of the implicit function. All right, so let me rewrite this. This was written as 2x. This was supposed to be 2x minus 3y like this, everything over x plus y. All right, which is equal to 2x plus y squared. This was our question. And we are supposed to find dy dx from there, 5 marks. All right, so what can we do? In this case, we can see that yes, it's difficult for us to differentiate direct. So instead, we can just cross multiply in this case, cross multiply and expand our brackets. Thus, this side, we are going to remain with 1 times 2x minus y, which is 2x minus 3y is equal to, we multiply these two, so we are going to have 2x plus y multiplying x plus y in this case. All right. So on the right-hand side, expand your brackets, in this case, 2x versus x, which is going to be 2x squared, 2x and y here, which is going to give us plus 2xy. All right, we move on to y this time. So it's y times x, which is going to give us xy. Then y times y in this case, which is going to be y squared. We have expanded our brackets, collect like term, in this case, collect all terms to one side of the equation. In this case, if it is like this, so that we can collect where there are common terms and subtract if it is like that. So meaning to say, by just doing this, we're going to obtain 0 is equal to 2x squared plus 2xy plus xy plus y squared. I'm going to take these terms, 2x to the other side. It is going to be negative 2x minus 3y to this side. It is going to be a positive 3y. Do we have any like terms in this case? All right, there is the part of xy and xy here. All right, that's the only part. So meaning to say we're going to have 2x squared, 2xy plus 1xy is same as we're going to have 3xy. There we add 2 versus 1. All right, the rest is going to remain as it is, plus y squared minus 2x plus 3y. So this whole part is supposed to be equal to what? To 0 now. All right, so this is where we are. What we are supposed to do now at this stage is to find the derivative of y with respect. This is the statement that we are all used to obtain in our exams. But there it was just, you're supposed to expand your brackets, this and that. So let us check what we have here. We can differentiate. Here there's a product. We've got two functions, u and v. So we're going to use our product here, which is u, the first derivative of v, plus the first v, the first derivative of u in this case. All right, here it's fine, here it's fine, it's fine. All right, so let us find our derivative. The derivative of 2x is going to be 4x subtract 1, so that's 4x. Okay, plus we move on to the product. So u, which is 3x, is going to be 3x times v, which is the derivative of y here. Remembering the derivative of y times dy dx, always when you're differentiating a function for y. So y, its derivative is going to be a 1. So that's 1 times dy dx, all right? Plus our v, which is y. So this time we take it as it is. The derivative of u, which is 3x. So 3x, the derivative of 3x is going to give us a 3. All right, y squared is a function of y this time. So we move on. The function of y is derivative first. That is 2y times the derivative of y with respect to x. Here we've got x, so there's no need to worry. So we're going to have negative 2. 3y is a function of y, so its derivative first. The derivative of 3y is 3, but your answer multiplied by dy dx. That is the whole concept. The derivative of 0 there, that's a 0. Collect your terms together. That is got dy dx. We can just combine our terms, or before that we can just rewrite in a way that is understandable. That is 4x here. Here you multiply 3x times 1, which is going to be 3x dy dx. All right, y times 3, that is going to be 3y here, plus 2y dy dx. Okay, minus 2 here, plus 3 dy dx. So it's just rewriting so that we properly see our terms. So we need these terms with the dy dx on one side of the equation. So we're going to leave these terms. That's 3x dy dx, okay, plus we have got 2y dy dx here, plus 3 dy dx again. So that is, we have left this so that we can factor out the dy dx. All the other terms without dy dx, this term and this term and this term, we are going to transpose them to the other side. So meaning to say 4x to this side is going to carry a negative, all right? It was a positive. 3y is going to carry a negative. Negative 2 here to this side is going to carry a positive. So that is, we can factor out the common term, which is our dy dx, the one that we wanted from one side of our equation. By factoring out dy dx, we are remaining with what? This is going to give us 3x plus 2y plus 3 in this case, which is equal to the whole of this expression on the other hand, minus 3x minus 3y plus 2. Having this, we can see that dy dx is now left as a single term. So you divide by this whole bracket so that you remain with your dy dx. So therefore, at the end, we shall say our dy dx is equal to this side as it is, which is minus 4x minus 3y plus 2 over the whole bracket that we have of 3x plus 2y plus 3. So that is how we're supposed to answer these typical questions. So it depends with the conditions that you'll be given. It actually depends. It can depend with how the question is given for that particular part that you have. But what is important is that your simplification should be done properly. Your derivatives should be taken properly in this case, all right? Expansion of brackets and so forth, which is in this case from the expansion of brackets, making sure that our brackets are being expanded properly. All right, so in this case, that is what we're supposed to have. Let us check if there is any part that is mistaken or so forth, but let's just hope that is what we're supposed to have at the end. All right, seeing here, let me check this supposed to be, all right, this is supposed to be 2x here. We've got 2x and y here. So this was supposed to be 2xy at the end. How 2xy, we have it here. Okay, so meaning say everything is fine here. So let us just cross check this, and but that is how we can have this derivative, guys. Let us try to revise as much questions as we can. And let us meet on the comment section for any other part that we think that is not understandable, so that we can check on it on separate classes.